are joining too. Welcome, welcome. Thanks everyone for joining. Happy Wednesday. Happy October 1st. Yeah, so as we get going, as people are joining in, we're going to go ahead and start a poll. So this is a poll just to kind of get to know who's in the room. Uh, and then after we end the poll, look at those responses, we'll go ahead and get started with our project highlights, intros, and explanations of the networking session. So Christopher just went ahead and started our poll. So if you could answer those questions, that would be great. And we'll keep this open for a couple minutes as everyone's joining us this afternoon. Yeah, just questions about um, what best describes your organization, where you're coming from. Have you engaged with our group before? Uh, Whether or not you're going to be wanting to join certain breakout rooms, what you're most looking forward to learning about today, and maybe what's fueling you. Are you on your third cup of coffee? You're just on those good vibes. Yeah, how everyone's doing today. So welcome in for those of you who are joining. We have a poll going, so before we officially get things going, we will record those poll responses. And we'll keep that open for a couple of minutes as people are joining in. And again, welcome everyone. Happy Wednesday. Thanks for joining the Rural Heat Islands project highlights and networking sessions. We're really excited that you all are here today, and we're excited that you agreed to spend an hour and a half with us on your Wednesday. We'll keep that poll open for maybe about 30 more seconds as everyone's joining in. Again, we're just trying to get to understand who's in the room today, where you're coming from, what you're excited to learn about today. And again, this meeting is recorded, so if you're unmuted, make sure that you're muted too, just in case you have any background that noise that might come through. And again, my name is Corey Monteverde. I'm going to be your host today. Christopher will be monitoring the chat and in charge of the timing and breakout rooms and the poll. So we're excited to be here today. But we'll go ahead and close that poll now. So Christopher, do you want to end the poll? We're going to go ahead and share those results. Okay, so it looks like a lot of us are from research institutions and academic backgrounds. We have some state and federal agencies, nonprofits, local government. Great, thank you. Welcome, everyone. And we have, a little bit of a split between who's engaged with us and who hasn't, which is exciting. So welcome those who haven't been engaging with us yet. We're excited to meet you and excited to engage right now and in the future. And it looks like there's a lot of split between what we're all excited to kind of jump into and learn about today. So that's really, really great. We're going to learn about a lot about what our project has been focused on and a lot of the highlights that we can share back to you today. And it looks like we have a lot of public health enthusiasts in the room, which is great, kind of remote sensing and data tools and apps. So that's great. We're looking forward to talking more and diving deeper into these topics during our breakout sessions later today. And it looks like most of the people in the room are fueled by coffee. Me personally, I am fueled by just good vibes today. So we're excited to be here with you all today. And we will go ahead and get started. My name is Corey Monteverde. I am a researcher on the Rural Heat Islands team, and I'll be your host today. My colleague Christopher is in the chat and will help manage Q&A, timing, and all the breakout rooms. So if you need anything, let us know in the chat. And with that, I'll go ahead and get started. All right, so Christopher, let me know if you can see that all right. Look good? Okay,
Looks perfect now.
awesome. Okay, so today's webinar will cover project updates, data tools, public and health findings, and more. And again, we are the Rural Heat Islands project. And today we're excited to bring our project highlights and engage in networking breakout sessions at the end of all of this. So just some quick meeting housekeeping. We'll introduce our project, and one of our community partners will jump into our project highlights and Q&As up until 12:50. We'll take a quick 5-minute break, and then we'll break out into our rooms for about 20 minutes. And then we want to come back and share and discuss everything that was discussed in those breakout rooms to kind of engage some more, see what we want to work on into the future. And just a reminder, this meeting will be recorded. And if you have any questions while we're presenting, please post them in the chat because we're going to go through all the presentations. And at the end, if we have time for the larger meeting questions, we'll get to those at the end. And we'll talk more about the breakout rooms a little bit later, but just wanted to give you a quick overview. Again, there will be 3 rooms: public health, climate and remote sensing, and data tools and apps. So make sure you stay with us so that you can dive deep and discuss further with all of our team members here. So to get us started, we'll have an overview of the Rural Heat Islands project, RHI for short. You're going to hear us probably say that a lot. And we'll also get an insight into community work from one of our partners. So first we'll hear from Trent Biggs, who is our principal investigator and has been leading this work for the past 2 years and probably longer than that. So Trent, I will hand it over to you.
Great. Thanks so much, Corey. And so great to see everybody here today. Thanks for coming. So, the motivation for the project is that there are a lot of farm workers in California. They're tens of times more likely to die from heat stress than other workers. There's been more than 150 deaths in California over a 16-year period. And heat also leads to higher injury rates, lower productivity, and kidney disease, among other chronic illnesses. Imperial County is the focus of our work, where there's 250,000 farm workers on a seasonal basis. And Imperial County also has the highest heat illness rate in all of California. So hence our focus. So next slide. So the subtitle of the proposal or the project is Mapping and Mitigating Farm Worker Exposure to Heat. And we have a website that you can look at for more information. We're grateful for the funding, principally from the University of California Office of the President Climate Action Initiative, supplemented by student support through USDA and NOAA SESRST. And I have the details of the funding down there. So next slide. So this project brings together specialists in remote sensing, climate science and modeling, data visualization, public health, and farm worker advocacy with PI investigators from SDSU, UC Santa Barbara, Líderes Campesinas, as well as logistics support from the University of California Cooperative Extension Office in the Imperial Valley. So next slide. The overall objective is to map trends in rural heat indices, and we'll talk about those different indices, measure physiological heat stress on farm workers themselves, and to co-produce knowledge on the heat stress exposure and both dissemination and mitigation strategies for farm workers in Imperial Valley. Next slide. So we've got 6 different activities that you're going to hear about today. One is mapping hotspots and trends with both remote sensing and climate modeling at coarse resolution, looking at connections between different crops and heat using high resolution remote sensing and climate models. Third part is farm worker heat assessment with both community surveys and in situ air and body body temperature sensors. Fourth brings together those three components to try and model in situ stress as a function of climate and remote sensing variables. We then visualize some of the results, including additional forecasts of heat indices into a web tool and some portable apps. And part six is getting community feedback on those apps and revising those apps to best meet the needs of the community. So you're going to be hearing about all six of these different activities today. And with that, I'll hand it back over to Corey.
Amazing. Thank you, Trent. Now I'd like to invite a representative from LeaderAce to share a few words about their role and involvement in the project. This team has played a key role in leading community engagement, and we're excited to have Brianna from LeaderAce who will give us an overview. So, Brianna, hopefully you're in the room here today and can give us a quick overview.
Hi, everyone. Good afternoon. I'm Brianna. I'm with Líderes Campesinas. We're a nonprofit organization that advocates and educates farm workers. We partnered with the Rural Heat Island Project because our community trusts us and we built strong relationships with them in the Imperial Valley. As part of this work, we connected participants to the project and shared information to our agricultural community of how the potential risk of working in extreme heat conditions. Thank you.
Thank you, Brianna. Okay, so now it's time to hear highlights from all of our research leads on four main project areas. So we're going to hold off on the questions until the end of all the presentations. Again, if you have questions, please drop them in the chat. Again, if we have time, we'll answer a few of those up until 12:50. So without further ado, our first topic today is climate modeling and forecasting, presented by Sagar, Callum, and Fernando. So Sagar, I will go ahead and let you lead us off.
Yeah, thank you so much, Corey. It's great to see many familiar faces here. Thank you so much all for being here today. There is a lot to talk about, but in this today's talk, I will mostly talk about the use of a weather model for heat stress mapping and forecasting in terms of wet bulb globe temperature. And I will also talk about rest break requirements for farm workers and also heat exposure by crop types. Next slide. Yeah, so maybe some of you are familiar with what is wet bulb globe temperature, but just a quick overview, WBZT is a gold standard of measuring heat stress because it accounts for the impact of humidity, the solar or thermal radiation, and the air temperature. So it has different weights for different components. For example, wet bulb temperature, a measure of humidity, has 70% weight. Black globe temperature, which accounts for the radiation impact, has 20% weight, and dry bulb temperature or air temperature has 10% weight. So we use WBZT to understand heat stress among the farm workers, and we use a weather model called WRF because it can simulate surface temperature, winds, humidity, and radiation at high spatial resolution. So it can resolve heat stress at farm or city scale. And also it allows forecasting of WBZT, and also it allows us to capture the local features like irrigation, which also impacts the WBZT. And our results shows that including irrigation reduces the bias in air temperature and WBZT, which is very common in coarse resolution models. Next slide, please. So I think there is a lot of interest in policies. So I will talk about the policies on heat-related rest breaks here. So there are three different guidelines that provide rest break specifications. These are based on three different heat indices. One is wet bulb globe temperature, and this is specified by National Weather Service. It is not enforced. And another is the air temperature-based rest break recommendation, which is actually an enforced policy. You'll find it in California Code of Regulation Title 8, Section 3395. It requires the employers to provide 5 minutes rest break every work hour when the temperature exceeds 95. And there is another regulation, which is adopted by federal OSHA in its new proposed heat rule that is under public hearing right now. And it also requires the employers to provide 7.5 minutes of rest breaks every work hour when the heat index exceeds 90 degrees. So these are the guidelines that are available. Next slide. And we compared these 3 guidelines for rest break requirements, and what we found is that WBGT-based calculation actually shows the highest rest break requirements and also shows high spatial temporal variation. Next slide. And what we found is that, the rest break requirement is not a static thing. It also varies by work shift hours and the seasons, because the exceedance of those thresholds that you saw in those guidelines actually depends on the work shift hours and seasons. So if you want to know more about this policy, we have already published these results in the paper that you can see on the right. You can follow the QR code. Next slide. And we also looked at how the heat exposure varies by crop types, because it looks like the labor schedules that is practiced in the field, which we gathered by interviewing farm workers and farm worker representatives. It looks like the labor schedule varies by crop types. Different crops have different harvest hours and harvest seasons or months. So that creates different heat exposure, as you can see here. In the next slide, I will show you how that next slide, please. How the heat exposure compares to the thresholds given by NIOSH. You can see the red and blue lines are the threshold levels for acclimatized and non-acclimatized workers. If you see the effective WBGT for different crops, taking into consideration their harvest timings, you can see for some of the crops, even the acclimatized threshold is exceeded. For example, for canes and dates, because they have a lot of metabolic requirement, because they involve cutting and lifting and heavy works, and also their exposure is during the peak heat hours. Next slide. So there is a lot of things to talk about, but if you're interested, please ask me about these questions during the breakout session. How does irrigation impact heat stress? And are the weights of the WBGT equation appropriate for the desert regions? Do the existing definition of heat waves correspond to actual health impact? How does heat stress impact labor productivity? And can we predict heat waves on a subseasonal to seasonal scale? With that, I will hand over now to our colleague, Callum Thompson from UC Santa Barbara, who will talk more about the WBGT climatology. Thank you.
Hi, thanks, Sagar. So yes, I'm Callum. I'm going to show you some results from climate modeling of wet bulb globe temperature that we've been doing. We've been doing this using the same model that Sagar described, the WRF model, but over a longer period from 1991 to 2020 for the summertime. And we've also bias corrected this model, removed the biases in it so that we could get a most accurate assessment of wet bulb globe temperature as we can get. And so we can better answer questions like this one: where are the hotspots of heat in Imperial Valley? So on the left here, this panel is showing the average daytime conditions. And so what we see is what one might expect. The wet bulb globe temperature is highest in this hotspot towards the south, in Calexico, Mexicali, along the border, about 92 degrees Fahrenheit. But also we have this more rural kind of like hotspot, the little orange bit towards the Salton Sea in the rural area where the valley is below sea level. So that's a kind of considered like a macro rural heat island, if you will. And that's very, very important for people that are working in that area. And then on the right panel, we have the average nighttime conditions, and we recover the urban heat island effect in the big towns of Calexico and El Centro and Brawley, but also around the outskirts of the Salton Sea towards the top of that image. And the average conditions there are about 68 degrees Fahrenheit at night. So that's how the kind of spatial maps look for wet bulb globe temperature in the valley. And on the next slide, we can also ask how does heat stress change across the season? So this is the average wet bulb globe temperature at these points, at these locations on the y-axis here within the valley. So like top is red, urban, below that green is cropland. And then on the x-axis, we're seeing how that changed across the summer. And what I want to bring your eye to is that heat stress increases up to a maximum of about early August, and then there's this kind of dip. There's this break in wet bulb globe temperature for about a 2-week period in early August before it recovers again. You can see that on the top right panel with that purple. You see the dip there, but you don't see it in temperature. So this is showing you how wet bulb globe temperature can see patterns of heat stress that temperature cannot. And then on the next slide, what we got here, we have how often are these heat advisories, the one that Sagar mentioned about from the National Weather Service, how often are those exceeded in the climate simulation? So what we're showing here is the heat category from those National Weather Service thresholds for every day in the simulation period for across summer, which is the x-axis, and then for every 30 years going up the y-axis. And so the color of the box on that day is what the heat category would have been. And so immediately you're drawn towards this preponderance of the pink, the highest risk category days when wet bulb globe temperature is more than 90 degrees Fahrenheit. And also you see that if you compare the first decade of the simulations to the most recent decade, then we're seeing fewer of the green days when there's no risk, going from about 31 to 9 days at Calexico, and 69 to 39 days in the crop field areas where it's a bit less frequent. And those no risk days are being replaced with higher and highest risk days. So there's increasing trends of wet bulb globe temperature and preponderance of heat exposure. And on the next slide, we can see how that manifests in urban versus rural areas. So this is the average wet bulb globe temperature across the day, where we have in the blue curve, we have the average in the 1990s, and then in the red curve is the average across the most recent decade, and the black dots are showing you where that warming trend is significant. So we're seeing warming during the day is very significant, rising about 1 or 2 degrees Fahrenheit overall. But notice if you look at the rural curve, the bottom corner, the blue and the red lines overlap. So there's increasing heat during the day, but at nighttime, there's actually no trend there. But overall, we're still seeing more exposure to high wet bulb globe temperatures. There's about an extra 3 hours of wet bulb globe temperature in this red NWS category above 88 degrees Fahrenheit compared to the 1990s. So more risk for people who are working out there in the field. And then that brings us to this slide. So this work now has been published in a paper in the top right there, if you want to go have a look at it. But also in the breakout section, we can talk about why there's that break in wet bulb globe temperature in early August, or wet bulb globe temperature as a metric overall. How is that the best metric to be using? We think it is. What do these trends mean for the future, and how do we remove these the biases to get the more accurate prediction of wet bulb globe temperature? But with that, I'll hand it back to Fernando now, who will talk about forecasting. Thanks.
And
Thanks,
Fernando,
Paolo.
sorry, I don't want to interrupt, but maybe to count for time, maybe just present for a couple of minutes, if that's fine.
I'll try to be very quick. So, hello everyone. My name is Fernando de Sales, and this work is actually one of my master students' work, and we're trying to evaluate and improve 7-day WBGT forecast in the Imperial Valley. Next slide, please. So, quick here, we looked at the national weather forecast for WBGT, and we noticed that it tends to underestimate the heat in the valley. Everyone here at one point has looked at weather forecasts to plan their day. So a good weather forecast, an accurate one, helps not only farmers, but farm workers, anybody that relies on long extended forecasts. We're talking about 7-day forecasts here, not the next day. So next slide, please. So we use the National Weather Forecast system, and we try to improve that forecast to see if we could perhaps, capture better the hot days in the valley. We developed a machine learning model, which I can talk more about later in the breakout sessions. And again, our focus was primarily on 7-day afternoon forecast. That's the peak heat, and we're talking about long-term forecasts here. Next slide, please. So we rely for this, we rely on some weather station in the valley. We selected 4 stations that have a long record of data. And the results I'm about to show are based on these 4 locations in the valley. So 2 more towards the north and 2 towards the south. Go ahead, Corey, please. So Corey, can I get one more click on your mouse, please? Yeah, so I'm just gonna show some of the more important results. So this that I'm highlighting here in red shows that the corrected model means once we apply the correction from the machine learning, we get fewer missed and safe days. So the original forecast predicted as this would be safe days to work in the afternoon, or temperature be above 84 degrees Fahrenheit. However, our correct model was able to do better. Next, please. So also the model was able to predict fewer false alarms. So those are days where falsely simulated or predicted as being hot days, but actually were not. So our model got better there. And also the model was able to better predict unsafe days altogether, which is the lower corner there. This is my last slide. So this just shows the correction from our model does improve the results. So we have here blue bars, which shows the uncorrected model, just the raw forecast from the National Weather Service, and the yellow ones are the corrected models for the 4 stations. So I'll be happy to talk to you more about how we got this result and what's in the future for our sub-project. Thanks.
Thanks, Fernando. Sorry to rush you on that one. So our next topic is going to be remote sensing, and this is going to be presented by Trent. So Trent, I'll hand it over to you again.
Yeah, thanks a lot. So remote sensing data can map heat and land surface temperature at even higher spatial resolution than the high resolution models, at 1 kilometer with MODIS and at 30 meters with another satellite called Landsat. So we wanted to leverage that to understand if land surface temperature has changed over time. Does land surface temperature differ by crop type? And how related is land surface temperature to air temperature, especially at different heights above the land surface? And I'll talk a little bit about the significance of that. Next slide. So this is the results of the trend analysis that show the number of trends in the number of days with high land surface temperature greater than 35 degrees Celsius or 95 degrees Fahrenheit. And the red indicate where there's been a significant increase in the number of days with high land surface temperature. Between 60 to 80 in dark red and 20 to 60. And next slide. You'll notice that there are some significant trends around the Salton Sea where there's been exposure of lake bed. There's been a big trend in temperature, land surface temperature there, but also in some of the solar panels in the Southwest, and in some of the agricultural areas. So land use change or land cover change is a really important part of these trends. So in the next slide, we tried to separate out the impacts of land cover change and climatic warming. And so the box there highlights that crops, if you can consider both fallow and non-fallow crops, increased about 4.5 degrees Fahrenheit over the 20-year period. But if you take out the impact of land cover change, there's still a strong climatic component to this generalized increase in land surface temperature over the valley. So we can see with pretty high spatial resolution where there's been large increases in land surface temperature, both accounting for and removing the impact of land cover change and fallowing. So with much higher resolution imagery, 30 meters, we can assess how land surface temperature varies by crop types. And the big difference is between bare surfaces, which are 10 to 15 degrees Celsius. That means up to 25 degrees Fahrenheit hotter than cropped areas. So we've highlighted and we've observed workers working in bare earth environments for land prep. And so we've highlighted that as a significant, perhaps underappreciated risk area for farm workers, those who are working in land prep, irrigation equipment laying, and seed planting and stuff like that. But even within cropped areas, there's a significant up to 5 degrees Celsius or 9 degrees Fahrenheit difference in the land surface temperature. So what does that mean for air temperature? The next slide shows that we've made some measurements in the field of air temperature and WGBT at different heights above the land surface to understand the relationship between the land surface temperature and air temperature at those heights. Notably, most meteorological stations are at 2 meters above the land surface. And what we noticed is that those 2 meter weather stations are between 3 and 6 degrees Fahrenheit cooler than those near the ground. So that if you're near the ground, it's several degrees hotter than the weather stations suggest. So the actual environment experienced by the farm workers who are bending and being closer to the land surface is potentially significantly higher than estimated by weather stations, which is going to be an important additional component to understand when predicting and forecasting heat stress. So I think that's it for the remote sensing. And we can talk more in the breakout session.
Okay, thank you, Chet. Yeah, so our next session will be the tools and apps for heat risk monitoring and data visualization presented by myself and Riley and Ryan. So I will go ahead and get us started. So we brought AIHA's new heat stress app to Imperial Valley to conduct a pilot study with farm workers where they use the app in the field for an entire week. So this app is a free mobile app specifically designed for outdoor and indoor workers. It uses real-time WBGT data to provide personalized alerts and rest recommendations. And this is based on conditions like location, specific clothing that's worn, work hours, and workload. So overall, farm workers really liked the app, calling it excellent, useful, easy to use, helpful. And overall, it received a 9.2 out of 10 average rating for how likely they would recommend it to others. So pretty highly recommended. But a final takeaway from all this work is that farm workers use weather apps daily to guide their decisions, from what they wear out in the field to how much water that they drink. But they definitely want something that's hyper-local, very personalized, and they definitely want it in Spanish. So this is a perfect segue actually to our next speaker, Riley, who will introduce our second tool. So Riley, I will go ahead and let you take it over.
Great, thanks, Corey. Hi, everyone. I'm Riley. So now we can take a look at our second application. This is the SDSU iHeat app that we built from the ground up. We wanted to visualize heat risks based on WBGT forecasts. So bringing our WBGT spatial forecast for the region to the average user. It has several functions to select different locations, from searching, locating where the user is, or clicking on the map to get the WBGT risk category forecasted in the user's area. We've also built the whole application to be switched from English and Spanish with the click of a button. And it's built both for desktop computers and mobile devices, and available now on the web at rhialarm.sdsu.edu. And this is a paper that we're preparing now for submission in the coming weeks, describing our methods and development. And next slide, please. Great. And so an important part of this application is our integrated chatbot. It provides an interpretation of the WBGT forecast for the user. It identifies categories of WBGT at different locations for this human-machine interaction. And it also provides recommendations to mitigate heat stress. And again, it is bilingual, so it can interact with users in both English and Spanish. And this is a quick demo. I'm not sure if time permitting, we have time to take a look at this, Corey. But this is just sorry, go ahead.
Yeah, you can give like a few second overview of that.
Great. So this is just a demo of using the app, selecting a new location, setting the forecast time. Within the next 36 hours, you can select a location and get that risk category. And then you can open up the chatbot to ask a couple questions, get more information on what is WBGT for the average user. That green button sends a screenshot so we can have some spatial analysis of WBGT forecasts in the area. Great, and this is another paper in preparation for submission describing the methods of this integrated chatbot. And now I can hand it over to Ryan to talk about our next application.
Thank you so much, Riley. Thank you, Corey. So this next application was built from the ground up using open source frameworks. It is a 3D digital twin of the Imperial Valley. You can look at it on your computer, on your mobile phones or tablets, any device, entirely in your web browser. It's a fusion of data from climate to health and socioeconomic records, so a true data integration platform. WBGT data features prominently in this. It allows for historical data analysis, for risk analysis. It has several customizable and data layering features so you can see the interaction between data sets. And we invite you to please check out the link on this and explore the digital twin for yourself. Next slide, please. And in this slide here, this just shows some of the analytical capabilities of our tool. It has a comparative time series. So when you're looking at gridded data sets like WBGT, you can select multiple points on the map within the Imperial Valley to view a comparative time series across those different sites. You can look at trends, summary statistics, and options for data downloads. The data come processed, and you can download it to your computer in your preferred format. Next slide, please. And finally, there will also be a paper coming out on this. The journal is to be determined, but there will be a technical paper on how this application was built and some of the methodologies and frameworks we use to build it. Thank you.
Amazing. Thank you, Ryan and Riley. Yeah, so make sure to pop into their breakout room, ask for another live demo, ask about their tech stack, and yeah, maybe suggest some improvements for them. All right, so we are heading into our last topic today, which is public health, presented by Nicholas and Haley. So I will let both of you close this out for today.
Thank you, Corey. So now let's talk a little bit about like what is actually happening in the field, because at the end of the day, the farm workers are the ones that are mostly affected, and we want to really understand what is their perspective and their actual measurements. So for that reason, the goal of this section was to evaluate farm workers' heat exposure in Imperial Valley. We set up a few objectives that is gonna happen on the field. One of them was to recruit 300 farm workers between the years of 2023 to 2025. And then we were going to assess the heat strain among all those workers during all seasons for these 2 years. Then the plan was to determine differences of heat strain levels between occupation, environmental factors, like the ones mentioned before. And we're also planning we plan to determine what factors are associated with workers' heat strain. Next slide, please. So in order to do that, we actually end up have to use different methods. One of the methods we use is like one that you've been hearing for a while, which is WBGT assessment. We end up using these monitors that are able to collect those measurements. Then we use we call it the belt, but it's pretty much a monitor that allows us to collect skin temperature, heart rate, and also accelerometer, so how fast they're moving in the field. And then we were also using a questionnaire where we were able to collect information about not only the demographics, but also like how do they feel in the field, like in terms of their exposure to heat, what barriers they may encounter to control or reduce heat exposure. So we try to incorporate all these methods at that moment. And we also have like a qualitative assessment that Haley will talk about in a little bit. So you thought we were done with WBGT, so we're not. So we actually, when this happens in the field, we have to also consider the clouding factor. So for that reason, when I'm using when they're using the OSHA clothing factors that pretty much in most of the cases, after understanding what they answer and what they were wearing, it adds about 3 degrees Celsius to the WBGT values collected in the field. So we end up incorporating those aspects. And in addition, you probably already remember from Sagar's presentation, there's like a breakout into like what is recommended and when, like for example, workers pass the action limit versus the threshold limit. And it also depends how hard they're working. Like for example, if they're working, their workload is light, then you can see that the levels that they can be exposed to in terms of WBGT are higher, right? Like if you look at the acclimatized workers, it's about 86 degrees Fahrenheit or 30 degrees Celsius. So we're trying to understand this also as well in the field. So next slide, please. In addition to that, we're also relying on this index, which is the physiological strain index. And the idea of this index is to incorporate core body temperature, which is an approximation that we're calculating from a skin temperature that has been proven before. And then we also incorporate the heart rate to calculate the PSI that you can see the formula that is down there. And then we also try to put it in these values that you can see like low, moderate, high, very high exposure. So that way we're able to understand if the participant or like the worker itself is having a heat strain or not. So most likely if they are on the high level, like having a 7 PSI, the caution needs to happen. Like there's recommendations in terms of stop working because the physical strain is too hard. Next slide, please. So now, after I show you like those methods that we use, I would like to briefly show you some of the results we have. Some of them are preliminary. As you can notice, we have a population of 272 participants in this case. Our goal was 300, but we're still incorporating some of our data at the moment. We just finished the field sampling like 2 weeks ago, last month. So anyway, in general, you can see that out of these participants, there were more males, not relatively that many compared to females, but there were some, and then, which is unexpected. Usually you will think like, oh, female farm workers are not that common. I will like to argue otherwise. It depends on the jobs, right? So what type of jobs they were at the time of the job, of this particular job they were working, most of them were working for over a year conducting this job. Then the time with employer, as you can see, some of them have been working with the employer for over a year as well. And then the primary activities, most of them we kind of categorize it as plant work. That means pretty much anything related with harvesting, trimming, anything that you will end up touching some of those crops. And then there's maintenance, which includes land preparation, and as well as like some sort of mixture between those maintenance and plant work. In terms of payment, you can see that the majority of workers are paid by the hour. We thought at some point that maybe some of them are going to be paid more by the pound, which is not the case. And the different crop types that we end up noticing, the majority of the workers work at ground level, like for example, working with on onions. Next slide, please. And then we did also ask them in that questionnaire questions about extreme heat, like if they felt that they have been exposed to extreme heat while working. And as you can see, the majority, which is almost 80%, end up saying that yes, they have been exposed to extreme heat, and only about 20% say no. Some end up saying sometimes. In terms of receiving heat strain, which is very important, heat strain training, the majority say they have received some heat strain training. In terms of physical work, you can see that the majority consider that it was heavy physical work that they are usually conducting in the field. That's about like 50% of the participants, and then about 28% of the participants actually say that it's not much of physical work, which was surprising to us. Chronic disease, we asked them if they have been diagnosed with chronic disease. The majority end up saying no. We do have a group of concern that is about 22%. And finally, we did ask them about health illnesses, symptoms. So we try to incorporate if they end up having more than 3 heat illnesses, at that moment, then we put them as yes, and the ones that have less, put them as no. You can see that this is concerning and doesn't fully match with the response about heavy physical work. Next slide, please. So this is an example of like what are we seeing with the belt monitor that I was talking about. This is the core body temperature that a worker usually goes through. This is actually all the workers together in this figure. So you can see, for example, that in the summer only, well, I will say like because I know these values, only 54% was like below the 38 degrees Celsius. While maybe about let me see, 12% actually even passed the 40%, the 40 degrees Celsius mark, which is very important. That's when actually, if the body actually passes the 40 degrees Celsius mark at the core body temperature, you are really prompt to have like a heat stroke. So it's very concerning. And we also noticed that fall, even though the temperatures are not as high, the ambient temperature, there is still some participants, about 8%, that end up passing that 40-degree mark. Next slide. And then that conversion, as I mentioned before, the core body temperature information also is put together with the heart rate, and that way we're able to calculate this PSI, the physiological strain index, and we noticed that about 91% of all participants pass or reach at some point that mark of 7. I don't know if you remember that mark of 7 during their work shift. Next slide, please. These are some figures that show specifically PSI during different seasons of these 272 workers. You can see, for example, here that about 14% fall. Well, I guess if you look at fall, the participants in fall, they spend most of the time on a PSI of 5 to 6, but then about 18% spend their time in like a PSI over 7 or more. And then in terms of the summer, which is one of the seasons that we care the most, as obvious, we can see that about 20% spend their time over the 6 to 7 PSI. Next slide. Then we did the same
And
thing.
then Nico, I'm so sorry to interrupt. Do you mind wrapping up in like maybe 30 seconds? Because I know Haley would like to share a little bit, and we can shorten our break as well,
Yeah.
which is really fine. Yeah.
So in terms of crops, actually, let's just skip all these figures. There's one that I wanna, can we go to this, 2 more? And then I'll just give the, okay, so one before, sorry. So this is actually, it's very interesting because then we end up using WBGT that you heard a lot, the effective WBGT, and then we combined it with the heart rate, and that the heart rate was actually allow us to calculate the metabolic rate. And then you can see here some workers are passing the action level in the summer is divided by the season. Anyway, this is divided by the full work shift. Then the next slide is actually, you can see that workers throughout hours, the hour average, you can see that some workers, regardless of the season, end up passing those marks. And then the summary, next slide, sorry. One argument that I do want to say is that ground level crops, which is the highest exposure that we notice on PSI, and similar results were found on WBGT. And I think that's mostly it. Next steps, we can talk about that in the discussion. Thanks.
We can skip this slide. We can talk about it in the breakouts.
Great. Haley, do you want to take a few minutes to discuss your qualitative work?
Hello, everyone. It's nice to see. I know I've met personally with most of you, and we can actually talk about most of these interview data in the breakout room. I know we only have about a minute before our lunch, and I want to make sure that everybody has time to have a break and get away, so we'll have more people in the breakout rooms.
Yeah. Feel free to take a couple minutes if you want. It's okay. We cut the break just a little bit.
So we also did about 30 interviews. They were in-depth, semi-structured interviews in order to get a context for all of these data that we're doing both on the public health and geography sides of the project. We ended up speaking with 14 farm workers across both Imperial and Coachella Valleys, 6 farm worker peer managers, otherwise known as mayordomos, and then about 8 advocacy group representatives. Some of you are here on the call with us today. from these organizations you see here listed. Next slide. So I want to touch briefly on the farm worker working conditions. Obviously, all of them talked about exposure to extreme heat, lack of shade, and inconsistent safety practices. And one of the big takeaways from this is that farm workers are taking breaks. Wonderful. However, they are not taking breaks based on regulations or recommendations, but mostly based on managers' personal experiences. And we can talk about in the breakout room how this might be impacting their physiological strain in the field. Also, they have mixed opinions on night shifts. A lot of people say, well, you know, a night shift is a great solution to avoiding high heat, especially during the summer months. However, from talking with farm workers, we see that some of them do prefer the cooler temperatures of working in the nighttime, but there are challenges for this, as any of us would face, including childcare, transportation, and being able to sleep effectively during the day. Shift work is difficult. In terms of rest areas and breaks, now shade is provided in many of these fields, as you can see in this photograph right here. This is an example of one of those shade structures that you might see. So tents, trailers, and vehicles may be provided. Sometimes they are not. Sometimes farm workers say that they get lucky if there's a tree in the field and everybody tries to huddle under that tree. But often these are not adequate to cover all farm workers that are in the field for that day, as you can see from this photograph here. And then in terms of fear of speaking up, there is widespread reporting of some stigma around asking for breaks. Now, some people feel more comfortable than others, depending on your peer manager that's in the field with you, but there is a fear of being seen as lazy, and there is some fear of retaliation and job loss. Next slide, please. So we can move on from this, but we can touch on this in the breakout room, but there is health and chronic disease reported across all farm workers we spoke with. Please go back for 1 second. And then the major economic and social impacts for folks, including very high electricity bills, especially during the summer, which is cost prohibitive for farm workers. Okay, move along. Next slide. Many enforcement gaps were identified, including inconsistent policies across farm workers. And then, like I said, you know, some people do feel backlash about slowing down or taking breaks. Next slide. We did speak with peer managers. So these are the people in charge of when those breaks are for farm workers. One of the major takeaways is that they do not have extensive training. They rely a lot on personal experience from being farm workers themselves for many years, which is wonderful and effective, but there is a lack of consistent training across peer managers in the fields. And these peer managers are the ones who are making the on-the-ground day of decisions about work schedules and adaptations to extreme heat. Next slide, please. Also, many of you advocates that we spoke with, you had some themes that overlapped. You had concern for farm workers across documentation statuses. There are services available to farm workers. However, with our current administration, use and outreach is way down, and that's concerning for you. Of course, resources and outreach are major challenges, as they are, you know, for most of us doing this kind of work. And then regulations to protect these farm workers are not necessarily adhered to. Fortunately, and this was a suggestion from one of our other advocates, is that spontaneous inspections are launching across the state, according to our Cal OSHA representative that we were able to speak with. Next slide, please. So participants did have suggestions, and we can go over this in the breakout room, but wonderful suggestions. And then next slide, please. So in the breakout room, please ask us about, we did work on some machine learning models to predict PSI. We are using these survey data and WBGT to try and predict physiological strain among farm workers. We also have calculated physiological strain of each participant across the workday and break times, which relates to those not adhering to suggested or recommended break times. And we have a lot more details about interviews since we have over 30 hours of data. Thank you.
All right, thank you, Haley. I am now going to let us go for about a 5-minute break. We'll still have a 5-minute break, so we'll come back at around 12:59. And at that point, we'll break out into our breakout rooms, and then we'll go over those when we get back. So yeah, feel free to get up, go stretch, grab another coffee, go grab your lunch, and come back at 12:59. And then we'll head to our breakout rooms then. So we'll see you in about 5 minutes.